So we're going to try notes just a little bit differently today. Instead of me standing up in front of you guys and talking the whole time and having to talk over us, we're going to do video notes. So you guys are on your computer. There's no distractions because it's just like I'm talking just to you, a class of one. Today we're talking about scientific notation. So because science has these really big numbers, like when they count the stars or when they tell us how big space is, and they also have these teeny tiny numbers, like how big an atom is, they make an easy way for us to write really big or really small numbers. And it's called scientific notation. So we're going to take a really long number and just shorten it up. So it's written as a product of two numbers. My first number has to be between 1 and 10. My second number is going to be an exponent of 10, which means my first number times 10 with some exponent. So whatever number is going before the 10 has to be between 1 and 10. My second number is going to be that teeny tiny little exponent. So let's talk about what that looks like. The first thing we're going to do is to create a number between 1 and 10 by moving the decimal. So if I'm looking right here at number 1, I'm going to make myself a little note. My decimal starts at the end. If I ever cannot see a decimal on a number, I'm going to assume it starts at the end. And I'm going to move the decimal behind the first counting number. That means if I'm looking from left to right, it's going to be behind the first number. So I'm going to make a few dots. You don't need to make them. If I move the decimal one spot, I still have a ton of numbers before it. If I move it 2 spots, I still have a ton of numbers before it. If I move it 3 spots, there's still a ton of numbers. 4 spots, 5 spots. Goodness gracious, 5 spots, 6 spots. It takes us 6 jumps to move that decimal behind the first counting number. So I took 1,855,000 and turned it into 1.85. We have to make sure that there's only one number before that decimal. The number of jumps, the number of times that I moved that decimal, become my exponent. So those 6 jumps are going to go right there, right up top of the 10. If our numbers are huge, that exponent is going to be positive. But if those numbers are teeny tiny, these teeny tiny decimals, oh, hold on. That is wrong. The number of jumps is going to be our exponent on 10. We already talked about that. If our number is huge, the exponent is going to be positive. But when it's tiny, like a decimal, like right here, our exponent is going to be negative. So let's look at number 4. I have a number before the decimal, but it's 0. 0 is not a counting number. So I need to move it behind the first counting number. If I move it, still only a 0. Still only a 0. 3 times, still only a 0. 4 times, still only a 0. But if I move it after the 5th time, after 5 jumps, I have one number before it. So now I can say 1 point, because I have that decimal, times 10. That 5 is going to come right here and be our exponent. So our answer is 1 times 10 to the 5th. You could leave off that decimal just because there's nothing after it. That would be okay. So what's going to happen is this video is going to pause. It is going to ask you to work out number 2 on your paper and then tell me part of the question. I might ask you for the whole answer. I might just ask you for the exponent. I might just ask you for the decimal number. I'm taking my decimal from the end and I'm moving it behind the first counting number. Once you put your answer on here, it's going to take you to problem number 3. And I'm going to ask you a question about problem number 3. Remember, I want to move that decimal from right where it's starting behind the first counting number where there is something other than 0 before it. Go ahead, the video is going to stop. You're going to answer 2, answer 3. Make sure that you're answering it on your paper. And then it's going to continue. And we're going to talk about backwards. So sometimes we talk backwards and we're going from scientific notation to what's called standard notation. Standard notation is just a normal number. So my exponent tells me the number of places that I'm going to move. So this 7 tells me that I'm moving 7 times. If the exponent is positive, we're going to take our decimal and we're going to move it to the right to make a huge number. So if I'm looking right here, I'm going to rewrite my 7.83 because I want to have plenty of room. I'm going to count 7 jumps. 1, 2, 3, 4, 5, 6, 7. 7 jumps total. I'm not just adding 7 zeros. I'm moving that decimal 7 times. It says to add zeros as placeholders. So I do have all these empty spots. So I am going to fill those with zeros. And that is going to be my answer. My exponent tells me how many jumps, how many moves I'm making. But sometimes that exponent is negative, like this right here. So my exponent is negative. I'm going to move my exponent, or my decimal, to the left to make my number smaller. Negative is going to make teeny tiny decimals. So I'm going to take that and I'm going to go left. 1 jump, 2 jumps, 3 jumps, 4 jumps, 5 jumps, 6 jumps. Make my decimal. Same thing. If I have blank spots, I'm going to fill them in with zeros. Your video is going to pause again and it's going to ask you some questions about number 6, number 8, and then number 9. I'll tell you on number 6, because it is positive, you're going to be jumping to the right. Number 8, because it is negative, you're going to be jumping left. And then on number 9, I'm not going to give you any help. Okay? But I do want to make a little note on this summary. Because I want, if there's anything we're going to mess up on this lesson, it's this. My exponent counts jumps. It's either me counting the jumps to move the decimal, or it's my exponent telling me how many jumps I need to make. They count jumps. They do not count how many zeros they have. Okay? I'm going to turn you guys loose. It's going to keep asking questions. Of course, if you need help, raise your hand. Ask me at any point. That is what I'm here to do. But I'm going to turn you loose. Let's go.